Okay, this is part two of developing our first template here for corridor modeling. So in the first video there, all we did was we brought in or we developed, you might say, the surface course and the binder course. We used some components to get started on the template. We said components or templates are made up of these components, but they're also made up of points. And so we can look at each one of these points. Now this point here, this left edge of pavement, so if I bring in the typical, of course it's going to be right at that point, the top of the surface, right at the edge of pavement. And we start off with corridor modeling by we're going to be basing everything to get started off of the PGL. So in this case, that profile grade line is the center line point, which was included in that component. And really, this is the only point that's not going to be constrained in any way. You see it says none on both. And that is because we're really just starting off from that PGL at a 0 offset. And so if you look at another point, like here, you will see that, okay, what defines this edge of pavement? And when we develop templates, we're not fully thinking about super elevated sections yet. We're starting off when we create our templates by just going with the normal crown, and then you see the super elevation flag up here. If the point is going to be associated to a super elevation, we're going to toggle that on. And so when we do get into those curves, that the software then knows to override that 1.5% cross slope and instead use our calculated super elevations. So, okay, now by default, the lane width was 12, and that is correct. You see below where it says 12, it says label. So that's something that is kind of optional that we use, and we do tend to use it for pavement widths and thickness, that sort of thing. Later, you'll see that we're going to use something called we can use what's called a parametric constraint. And because we have that label there, we can go back later, and that parametric constraint, we can override the width. So if we get into a case where the pavement is not 12 foot wide and we want to just key in whatever that width is, but not actually fully change the template, we just want to override it later in the corridor, we can do so. And that's what that's all about. So just looking at the points, just very quickly, like we said, each point has a feature definition, the super elevation flag. In this case, we've got the two constraints, horizontal and then slope from that center line. And we can also look at, the thickness of the pavement. And this is, again, very similar to, we've got that label just like we did on the width for surface course thickness. So that's 0.125. So that is an inch and a half, which is actually what we are using on this project as well. And we could look at the bottom of the binder also. And so right now that's set also to 0.125, which, this project, it's different. And you can see that number, is based off the bottom of the surface. So that's why it says 0.125. So that's what these constraints do. So we have a horizontal constraint in this case. We have a vertical constraint. And so that point is just looking up above at the bottom of the surface course, and then it's saying drop down vertically, negative whatever that thickness is. So in this case, I think our binder thickness was more than that. It was 2.25, I believe. And so you could have it just do the math for you. Let's see. Of course, you want to add in the negative. So it's negative 0.188 is 2.25. But because I only changed it on that one side, Oh, wait a minute. I think I just changed the wrong point. Let me, oh, this is nice that we do have undo. So let's do that one more time. So let's change that to negative 0.188, I think it was. Yeah, there we go. But now, to do it this way, we've got to go through and change every one of these points. And so that's kind of the whole idea of having some of these parametric constraints. If you have these situations where you don't want to have to change every single point, you can go back to this active template here, and then we can expand out our parametric constraints, which are those labels we just looked at, and then we could look at binder thickness, right click, say edit, and then that allows us to just type it in one time, and it will change every point that has that parametric label set. So negative 0.188, enter, and then all of the points should have changed, and yeah, it looks like they did. So now we have what the typical section looks like here. Okay, so next, and we can continue developing this template as far as we want, or as we develop, this is probably more common, as we continue to develop the project, we tend to save the work that we have so far and exit out of this template library and just see what the model looks like so far. Of course, all we did so far was just added that surface and binder course. And so let's see, let me rotate this view to look at where we're at. Yeah, so all we want to do is we want to apply that template from this point right here, the beginning of the gutter outlet up towards the beginning, the top of the hill, the top of, where the gutter starts for us. So in order to add a template, we're going to say here in the same workflow, new template drop. We're going to select the corridor, that's that yellow line, and then we are going to point to that template that we just created. And we can do that here on the fly, or what's associated to my cursor, on my cursor there, or I can go over to the dialog, hit those three dots, which is I guess what I typically do. I expand this out to our project templates, and there's that new template that we're starting to develop, which we'll give it a better name than that as we go. But let's go ahead and say OK. And so it's going to ask us, where do you want to start and stop that template? So we could either key in that station, or we could just dynamically do this. And then if there are station equations, it will take into account the station equations. And so it will know what region we're sitting in automatically. So that's the way I typically go. And notice we are going to go through the entrances, and that's okay, because we'll show you later how we can override that gutter and have it instead draft in for us the entrance. So really we want to start right at this point right here. Let's see. So I'm going to set my key snaps to right there to start there, which is great. Now notice I passed that station equation, and notice now it says R2 at the end, which means that we're in region 2. Again, I'm going to snap to that point, accept it, and accept the interval of 25 foot. And there we go. So we have started our modeling process. Okay, so there you can see the pavement. So now let's take a look to see what a cross-section would look like. So we're not really you'll see that we're not really developing proposed cross-sections as far as drafting in the elements, so to speak. Instead, we're just visualizing cross-sections. Up here in the same workflow, we have something called dynamic sections. So we're just visualizing a cross section. And so it's going to have us select that yellow line again, which is that corridor. And then it says, what view would you like to visualize that corridor? And so we'll select this view 4 here. And I'll just expand that out. And I'm holding down my control button here and rolling my button on the mouse here just to show you that I can dynamically change the vertical exaggeration. Or I can come over here to view properties and I could type in 2, for instance, which is what our cross sections would normally be. Just, you know, that's what we're normally used to seeing here in Illinois, the cross sections being visualized at an exaggeration of 2. Now, one thing you're going to notice right away is that, you know, we are in this curved section, so I can kind of toggle through here. You can see that I'm in the curve. You can see that the existing pavement was super elevated. We kind of see that here in the 3D model, so we're looking at all 3 views there at the same time. And of course, we can see that our normal crown of 1.5%, of course, is not going to work. And so we know that we're going to need to do something that is going to change that cross slope, something that's going to override that 1.5%. And depending on where we are on the curve, it's going to either be at full super elevation, which in this case would be probably 6%, being it's like a 60 mile per hour design speed and a fairly tight curve. So most likely it's going to be the maximum 6% in this roll section, or we're going to be in transition, transitioning from that normal crown to the full 6%. So we'll just toggle through this a little bit more. As far as using some of these tools to visualize, we talked about the vertical exaggeration. There's different ways that we can move around here to analyze, you know, different areas. We can, in this cross-section view, just hold the right mouse button down, and we could say locate a station offset via data point, which is one that's used a lot, because that way all we do is we generally can see in our plan view, we know generally, you know, where we want to visualize that cross section. Like, let's say I was to hover over this entrance, for example, and data point right there on our entrance and accept that. So that then allows me to visualize it right there at that entrance. And you can see it, it's the 331 plus 14.7. So that's exactly at the entrance. Or I can toggle through. If I would like to visualize, you know, on some particular station, I can come in here and I can override this right here, and I could type in 332 plus 00, for example, hit enter, and it's going to take me to, you know, that exact location to visualize the cross section. I know that when I developed that typical section, I created that edge of pavement at a 12-foot offset, but at any time I can temporarily visualize anything I like here. So place horizontal temporary dimension, and so I can hover over that edge of pavement, data point, go to the center line, data point. It's going to ask me, okay, where do you want the height? And now, like I said, this is temporary. This is not like on your cross-section sheets themselves. They're going to be dimensioned, but they're not going to use this dimension. This is just a quick dimension just for, you know, your own benefit for developing these cross sections, so you can see what you've got so far. And that temporary dimension is not going to be just at this one specific location. What it's doing is it's looking at the location of the points in that template that you developed. So even as you toggle through these cross sections, and even if that width was changing, if we had applied the super elevation, and you would see all of those dimensions change on the fly, but you would not have to go in and actually dimension every visualized cross section. It would just automatically do that for you, which is very nice. So I think what we will do next, as we're developing this template, is, and we wouldn't have had to have done this in this particular order necessarily, but because the cross slope is so steep at 6%, why don't we go ahead and calculate our super elevation and apply that super elevation to this corridor, so that as we develop the remainder of the template, it'll look a little bit more like the final product anyway. So let's go ahead and stop the video here, and the next video will actually be on super elevation calculations.